Welcome to this explainer. Today, we're diving into what honestly feels like a thrilling detective story. We're going to uncover and, more importantly, unlock a massive secret hidden deep inside today's artificial intelligence. If you've ever wondered how we're actually going to make AI faster, smarter, and just way more efficient, well, you are in exactly the right place. So let's jump right in.
For years now, we've kind of just accepted a fundamental limitation in how AI generates answers. It types them out, right? Token by token, word by word. It's totally linear. But what if it didn't have to be? What if an AI could break free from that constraint and explore multiple thoughts simultaneously? Answering that question changes absolutely everything about how we scale machine learning.
To get to the bottom of this, we're looking at a pretty groundbreaking new paper. It's from a brilliant team of researchers Xinyu Yang, Yuwei An, Hongyi Liu, Tianqi Chen, and Beidi Chen over at Carnegie Mellon University and NVIDIA. They provocatively titled their work Multiverse, Your Language Models Secretly Decide How to Parallelize and Merge Generation. And as you'll see, that title, it hits the nail on the head for the mystery they've uncovered.
Section 1. The AI Speed Bottleneck.
Okay, to understand the cure, we first need to investigate the disease, the core problem that's bottlenecking the entire AI industry right now. And that's the inherently sequential nature of large language models. We call these autoregressive, or AR models. Think of traditional AR models as a single-lane road. The cars, or, the words, they literally have to travel one by one. If there's a complex problem, the AI has to patiently process one step before it can even look at the next. But the multiverse idea? It builds a multi-lane highway, allowing the AI to generate multiple logical branches at the exact same time.
And here's the crazy hidden secret the researchers discovered. When analyzing long chains of reasoning, they found that in over 98% of complex tasks, current AI models are already trying to think in parallel branches. They're doing it implicitly. But because they're stuck on that single-lane road, they just don't have the infrastructure to actively enforce it. They're generating parallel logic, but they are entirely trapped in a sequential body.
Section 2. The MapReduce Paradigm.
So, to actually unlock this parallel capability, the team needed a completely new generative framework. And they actually found their inspiration in a classic computer science concept from the early 2000s called MapReduce. They built the multiverse model around a three-stage pipeline. Step 1 is the map stage, which takes a complex prompt and adaptively breaks it down into subtasks. Step 2 is process, where the model shoots those subtasks down our new multi-lane highway, executing them independently and in parallel. And finally, step 3 is the reduce stage, which losslessly synthesizes all those separate results back together into one cohesive answer.
Section 3. Data, Algorithm, and System.
Now, you can't just flip a switch and make an AI think in parallel. It actually requires a complete co-design across three main pillars. First up is the data pillar. For this, they built the Multiverse Curator. It's an automated, AI-assisted pipeline that takes standard sequential reasoning chains and restructures them into parallel, branching training data. And honestly, the best part? It does this automatically. No need for incredibly expensive and painfully slow human labeling. This pipeline created Multiverse 1K, which is a highly curated dataset used to teach the model exactly how to branch its thoughts.
Second is the algorithm pillar, where they designed Multiverse Attention. In a standard AI, every word pays attention to the words that came before it. But if you have parallel thoughts running, you absolutely don't want branch A getting confused by what branch B is doing. So, Multiverse Attention cleverly modifies the internal masks and position embeddings. This ensures that parallel reasoning branches can execute completely independently without crashing into each other, all while keeping the training process super efficient.
And finally, we have the system pillar, where they implemented the Multiverse Engine. Look, even with the right data and algorithms, standard AI hardware engines just do not know how to run parallel outputs. Enter the Multiverse Engine. It's a phenomenally smart dispatcher with a specialized interpreter. It dynamically reads control tags generated by the model and switches between single-lane sequential generation and multi-lane parallel generation right on the fly, with virtually zero overhead. Honestly, it's an absolute marvel of system engineering.
Section 4. Why Multiverse Matters. Okay, so what actually happens when you combine this curated data, this novel algorithm, and this specialized engine into a massive 32 billion parameter model?
Well, the results are staggering. After just 3 hours of fine-tuning, using only 1,000 examples, their Multiverse 32B model hit a massive 54% on the grueling AMY24 math benchmark. This proves a hugely critical point. Transitioning an AI to parallel generation does not compromise its intelligence. It easily matches the complex reasoning power of top-tier, strictly sequential models.
But here is why this truly matters, and why the whole industry needs to be paying attention. It achieves that top-tier reasoning while delivering up to a 2x wall clock speedup per generated token. Because the model is processing the math and logic across multiple lanes simultaneously, it gets to the correct answer in literally half the physical time.
When you look at the real-world metrics, it's amazing to see how drastically the latency drops as those parallel branches increase. And the model maintains this superior speedup so smoothly, scaling flawlessly from a single batch all the way up to 128. It just completely outperforms traditional linear models when it comes to sheer operational efficiency.
Section 5. The path to ASI.
This breakthrough isn't just a neat trick to make your chatbot type a little faster. The crucial takeaway here is this: we are no longer limited to scaling AI by just making its reasoning chains longer. We can now scale an AI's width. And by doing that, we unlock massive energy reductions for complex inferences. It creates an entirely new economy of scale for reasoning. As tasks get harder, the model simply fires up more parallel lanes, decreasing the time per task unit and keeping the overall latency nearly constant.
I really want to highlight a quote from the researchers here. They state, "This remarkable scalability showcases its potential to address extremely complex tasks in practice, offering a promising path towards artificial superintelligence." Unlocking this parallel economy of scale might just be the crucial missing stepping stone. We're finally giving AI the structural infrastructure to match the multi-threaded way humans naturally tackle complex problems.
So, the multi-lane highway of AI has officially been built. The framework exists to let models adaptively split, process, and perfectly merge their thoughts, leaving us with one final, fascinating question to consider. If our AI can now seamlessly think across parallel universes, what impossible problem is it going to solve next? Thanks so much for joining me on this explainer, and I'll catch you next time.